I'm James Brierton in Charlotte, and welcome to a special weekend edition of the Carolina Weather Group. As we talk, two commercial companies are delivering NASA science and technology to different locations on the moon. Firefly Aerospace's Blue Ghost Mission 1 launched on January 15th and is scheduled to land Sunday near a volcanic feature in the moon's northeast region. Meanwhile, Intuitive Machines launched its IM-2 mission on Wednesday and is targeting to land about 8 days later in a plateau near the moon's south pole. There are no astronauts aboard these missions, just robots, but the scientific answers we learn during these missions are intended to help us get humans back to the moon and onto Mars. And to learn more about the science being conducted on these missions, we talked to Dr. Nicky Fox. She is the Associate Administrator for NASA Science Mission Directives, and we spoke to her from NASA headquarters. Take a listen. Dr. Nicky Fox, thanks so much for taking the time, and welcome to the Carolina Weather Group.
Thank you.
We have two different private companies ferrying NASA science to the moon right now. Why two companies and why two missions?
Oh, well, so many missions. We have plans to have two landers going to the moon every year. So that's, this is a good cadence for us. Really, so this is the Commercial Lunar Payload Services Program, and our goal here is to actually create a sustainable lunar economy. And so working with these new companies, providing obviously funding support for them, but also some, subject matter expert support when needed, just to make sure that we have multiple companies able to go and deliver cargo, not just science. Obviously, for me, the science is the most interesting, but being able to actually deliver large cargo and things as we want to set up a sustainable presence on the moon. And so having this sort of lunar economy and having these new players that are coming in and doing our delivery service is just really exciting. So having both Firefly and Intuitive Machines on the way there, it's just kind of the way it turned out. We launched these, or the companies launched these landers when they're ready, and these two happen to be ready about the same time. So it's fortuitous that we will have the two of them operating on the moon at the same time.
I have so many follow-up questions and lots of them about the science, but a couple concept questions for our audience who maybe aren't as familiar with this just yet. Last February, we had IM-1, a couple missions to the moon from the globe. Here we are again in February. You kind of mentioned this as a regular cadence. Is this an orbital thing where every February the moon's really close by, or how did we end up kind of with these dual races year after year?
So for Intuitive Machines 2 in particular, we want to go to the South Pole, and so the landing site for them is about 5 degrees off the South Pole. They're at Mons Mouton, which is a really interesting geological region. It's about the size of Delaware. It's about the height of Mount McKinley. So it's sort of around there are some shadowed regions. We really want to be able to get into those shadowed regions and look for the presence of ice, of water, of volatiles. So that's why we have the drill, to be able to drill down with that. So that does dictate when we can go, because we need to get some sunlight to be able to actually have the solar panels on the orbiter, on the lander actually working. And so there's a sort of a window that makes the right time for us to send these missions that are going to the South Pole. The ones that are going to the equator, there's less constraints on those. They can go more or less whenever they're ready. But if we're going to go to particular regions, then sometimes that drives when we can actually send them.
I have like 10 questions to ask about the drills and the helicopter and all that jazz. But let me ask you this last conceptual question. There's a lot of conversation, of course, these days about government spending. So I'm curious, in your words, why are these missions worth the cost, and what has NASA done to save costs?
Oh, actually, by literally, we are going to be eventually, we hope, just paying for our cargo. And the delivery service is established. So really making these investments now, really working closely with our industry partners, and letting them actually sell excess capacity. So not everything on these landers at all, by any means, are NASA payloads, and any excess capacity they are able to sell to other commercial companies that want to go to the moon as well. And so making them sort of commercially viable is something that we're really keen to do. we have a history in NASA science of working really closely with industry. We always are looking for more ways to get more science into space for less money. So together with Intuitive Machines, we also launched Lunar Trailblazer, which is an orbital mission going to the moon. So sort of two missions able to take advantage of one launch vehicle. We also, I'll just throw out on the West Coast right now, we have SphereX and Punch launching together. So that's an astrophysics mission. And then we realized that the heliophysics mission to study the sun was going to roughly the same region, so needed to go basically the same kind of launch parameters. So putting those two missions on the same launch vehicle, doubling the amount of science we get into space for less taxpayer money.
It's a very exciting time to be a space nerd. You mentioned the lunar economy, Dr. Fox, and for me, I can't help but picture Apple TVs for all mankind and what they envisioned the moon would look like. I'm not sure what your favorite space show might be, but I'm curious to hear from you what you think the moon looks like for us in 10, 20, and 30 years.
I mean, I hope the moon is sort of a routine destination for us. That we are regularly delivering cargo, regularly having a sustained presence there, being able to kind of live and work on the moon. It's a very important step for us because obviously, we think of the moon lighting our way to Mars. We want to, and no one is more excited about going to Mars than me. The idea that you can send people to the moon, you can let them sort of figure out that it's difficult to get to Mars. It's a long journey. It's a long time to be in space. The windows open every 26 months for a good Mars mission. And so really learning to work and live and adapt to space, and also all the things that you need to know before you go to Mars, being able to prove those technologies on the moon. So really thinking of the moon totally as that sort of test playground almost, before we can actually go, or a sandbox, before we can go off to Mars. So
Right in our backyard, comparatively
regolith
speaking.
box, maybe it's it's a regolith box, not a sandbox.
Yeah.
There you go.
Let's talk about some of the science that's going up to the moon to help with these future Mars missions and future lunar missions. I was fascinated to hear that this mission overlaps with an eclipse that's happening on the moon because I know there have never really been the opportunity to survive lunar night. It gets too
Mhm.
cold, but this eclipse will be a little snapshot into what nighttime would be like. Let's talk a little bit about battery life for these rovers. What did they hope to gain scientifically by having this small eclipse window?
So actually, it gives us a chance to look at kind of how the solar wind and the regolith interact in this sort of changing illumination condition. And that's if you're going to survive the night, you really want to know how the regolith acts in that different sort of condition. So that sort of brief eclipse is going to just give us some insight into that. Obviously, our future landers, we have sort of the challenge to survive the night and actually be able to survive a lunar night. That's coming downstream. But this is sort of that sort of precursor into how does the interaction change? How does the condition on the moon change? Not just obviously, there's no light, but just, how does that actually affect your environment?
Speaking of the environment on the moon, you mentioned it briefly. The Micro Nova hopper seems very reminiscent of the Ingenuity helicopter. For anyone who's looking for a comparison, it's going to kind of hop off the lander here and go exploring. Is there a benefit to using propulsion technology versus a traditional helicopter or even a crawling rover for that little expedition?
Um, there's a very long answer to that, but just briefly, we you want to be able to go to these different regions easily. And sometimes with a rover, if the slope is very steep, if it's very rocky, different terrain, you really need to kind of map out that terrain closely to know if your rover can go up and down that safely. A hopper or a type of helicopter like this can actually just lift up and then land and do that sort of surveillance of the area. And that has proved to be really valuable, proved to be very valuable for us on Mars with the Ingenuity helicopter, able to map out the terrain that Perseverance was going to drive through. So that's really kind of the main benefit. You can sort of you don't have to worry so much. You have to worry about where you're going to land with the hopper, obviously, but it can actually map out that terrain. And so you can think of that as kind of the advanced advanced party doing the scouting, and then when we have larger rovers, carrying humans, carrying a large cargo, then we can actually map out whether the safe routes for them to go. So it's a really, really exciting innovation to have this one.
And one of the places I understand that Hopper wants to go is down into a crater where we haven't been
Mm-hmm.
before.
Yep.
What do we hope to find out in that crater? And B, why does it need essentially its own LTE cellular network, like it's got a cell phone, in order to be able to communicate from that crater?
I mean, it's sort of line of sight. It's difficult. You're going into a crater. It's like almost going through a tunnel. When your phone doesn't work anymore. So you want to make sure that it has its own network so it can communicate. You want to be able to maybe you need to command it to do something differently. So these again are all sort of proving out technologies that we're going to need more and more as we set up that sustained presence on the moon. But getting into a crater means you're into a permanently shadowed region. So something that the sun has not melted, has not touched, and is more likely to be sheltered from like impacts as well. So it's much more pristine, but it's also hard to do. Going into a crater again, if you've got a very steep wall, if you've got rocks, if you've got other things that you have to be careful of, this hopper can just go straight down, take the data, and then come back out. So really excited.
Yeah, it is very exciting. You mentioned the drill, Prime 1, if I've got my notes here correct. It's going to
Yes.
be drilling into that surface. What is it looking for, and how do we get the samples back?
So we'll actually do all of the sample analysis on the moon. It's sort of a pair of instruments. It's got the drill, and then it's also got this sort of mass spectrometer on there. So if you think about, it's kind of like when you look at elements in different ways, they have fingerprints when you take their spectrum. And so what it will do is it's going to drill down about 10 centimeters, take some samples, bring that up, and then analyze those. And then the next time it drills down, it will go down 20 centimeters. So it will kind of have these 10 centimeter bands as the drill goes down to about a meter. And so, that's the first time we've really been able to drill that well into the regolith. It can go through, can go through much harder regolith if we happen to get in a region that isn't just sort of more like a soft sand, then it can drill down into that regolith. So giving us that information, and I love the fact that it's doing it in sort of the 10 centimeter increments. So you really can build up, the idea of what that surface is made of. As a heliophysicist, I'll just say the interesting thing for me is that's basically a sort of almost like an archaeological idea of what our ancient solar system was like. So, what the solar wind interaction with the moon was like as the solar system and as the moon was forming, as the Earth was forming. It's a sort of a pristine record of what the interaction with the solar wind was like. So that's really exciting to be able to go down in small chunks to figure out where the best place to go to do the science is in the future.
There's a lot happening, even here in the short term, that is really exciting to look forward to, and a long roadmap ahead. As we wrap up this conversation, Dr. Fox, I wanted to ask you, this mission or anything else, what is one fact that you love to share with people when they come up to you and they want to talk about space and science?
Oh, I think it's probably going to be kind of a glib answer, but just the excitement of studying space. With NASA science, we do amazing science from the very center of the sun all the way out to the very edge of our universe, and we take images of where we. Actually, the SphereX mission that we're going to launch is going to basically be able to give us information about the tiniest time scale after the Big Bang. How did our universe form? And so I think it's just the big scale of what we do and how it impacts us. From all the great science that we do on the International Space Station in microgravity, how to grow plants in austere environments, how to safely do clinical trials of medication, from studying our own planet. It is our home. It's the only planet right now that we know sustains life, and we need to take care of it. We need to understand, how the weather changes, those big, huge sort of disasters, natural disasters that happen, how we recover from those, studying our sun, and of course, studying every planet in our solar system, and just understanding our place in the universe as we sort of answer those big questions like, are we alone in the universe? Is there life elsewhere. And so, I think for me, it's just the fascination of just the scale of what we can do to kind of, lead the nation and inspire the world with the world around us and the solar system around us and the universe around us.
I look forward to answers to many of those scientific questions. Dr. Fox, thank you so much for your time.
Thank you. Appreciate it.
We will continue to provide you updates about those missions on our weekly show, the Carolina Weather Group, where we are also tracking a severe weather outbreak for midweek, the timing, the locations, the impacts in that forecast as we draw closer to the event, which we expect in the Wednesday timeframe. Thanks to all of our supporters on Patreon and YouTube memberships who got early access to our interview with Dr. Nicky Fox. You can support our show and gain early access to upcoming podcast episodes by joining us on Patreon or becoming a member on YouTube. More to come on those storms, so stay tuned. Until then, I'm James Brierton. Be well.